Is Betelgeuse completely alone? But how come the companion star hasn't been found yet, even if it is a binary star? Its existence might directly result in the resolution of a deep-seated riddle in our minds. Since our Earth could theoretically fit into our powerful mother star 1.3 million times, it is no surprise that the Sun is frequently regarded as the ultimate object in the universe. Even while the Sun is undoubtedly magnificent with its almost 1.4 million kilometer diameter, we must remember that there are much larger celestial entities out there that would reduce our center star to a tiny dust particle. We are brought back to earthly astronomical truths by a brief reality check, and we discover that Betelgeuse is superior than the Sun in every manner. This red supergiant, which is around 650 light-years away from us in the constellation of Orion, has a diameter 800 times greater than that of the Sun. The brilliance of Betelgeuse likewise reflects this enormous disparity in size. In fact, it shines 10,000 times brighter in visible light than our source of life and warmth. The idea that exceptions validate the norm, however, still holds true in space science. As a result, when Betelgeuse abruptly lost its brightness in a matter of weeks 5 years ago, it presented researchers with a great puzzle. In fact, the star dimming was so noticeable that it was visible in the night sky. Betelgeuse typically experiences periodic variations in brightness, but in this instance, the darkening was more faster and more extreme than usual. A quick aside, a celestial body's apparent brightness is measured in astronomical units of magnitude. The smaller the magnitude value, the brighter the object seems to us. Although Betelgeuse is one of the 6th to 7th brightest stars in the entire sky, with a typical luminosity of 0.3 to 0.4 magnitudes, it darkened to 1.1289 magnitudes in December 2019, dropping it to the 21st position in the brightness ranking. Will Betelgeuse explode as a supernova soon? For a short time, there was a fear that Betelgeuse's brightness decline was related to an impending supernova since experts had to find reasons for this unexpected development, and because the red supergiant is already nearing the end of its star life. We recall that Betelgeuse already shines 10,000 times brighter than the Sun when it isn't mysteriously fading. However, scientists anticipate that its current luminosity will increase 16,000 times as soon as it violently explodes to say goodbye to the cosmic stage. Betelgeuse would appear to be between -9.5 and -1.5 magnitudes brilliant during this time. The celestial body will eventually be as bright as the full moon, according to some scientists, and should even be easily identifiable during the day. However, it is another different to ask when we may anticipate this brilliant display. Actually, the majority of experts no longer believe that the supernova will happen anytime soon. Initially thought to be a sign of a primordial show, it was actually a huge plasma outburst. This created a no less huge dust cloud, which dimmed the star by over 2/3, according to follow-up observations. As previously stated, Betelgeuse is nearing the end of its life cycle and frequently sheds significant amounts of stellar material to our earthly view. Convection currents carry this material from the inside to the surface, where it is expelled. Experts believe that the combination of high convection and expansion led the plasma eruption to be 2 to 3 times more intense than usual. Betelgeuse likewise undergoes 400-day cycles of expansion and contraction. Returning to the solar comparison at this point, we can observe that Betelgeuse is likewise ahead. During this event, its mass loss rate was almost 30 million times more than our Sun's. In summary, the expelled plasma most likely cooled in space before condensing into a massive dust cloud. This seemed to us as a massive shroud that obscured the star because it was in the line of sight between the Earth and the red supergiant. Another rotational conundrum is if Betelgeuse has ingested another star. Without a few additional riddles for astronomers to solve, Betelgeuse wouldn't be Betelgeuse. For instance, it appears to be rotating at a pace that is exceptional for a red supergiant, according to photographs obtained a few months ago by the ALMA Observatory's paired radio telescopes. In particular, the rotational speed is 50 times greater than what would be predicted for a representative of this spectral class. Exceeding 5 kilometers per second, Betelgeuse completely flips the stellar pattern in this context. In fact, stars tend to slow down as they grow. The other red supergiant predicted to rotate that rapidly is Betelgeuse, according to Jing Ma of the Max Planck Institute for Astrophysics in Garching, Bavaria. More precisely, the bipolar nature of the surface is responsible for the matching speed. One half exhibits a red shift of several kilometers per second, while the other half shows a blue shift. How can astronomers explain this unexpected rotational behavior? The premise of the first theory is that Betelgeuse is a cosmic cannibal, to put it mildly. Put another way, it might have ingested a companion star like the Sun when it grew into a supergiant some 100,000 years ago. In this case, the swallowed star transferred the orbit's angular momentum to Betelgeuse's outer shell, speeding up its spin as a result of the absorption of so much mass. Although a computer model was used to test this idea, there is also concrete data supporting it. Two zones of expelled star material were found inert on one side of the supergiant, according to images obtained a few years ago by the Herschel Space Telescope. These shell-shaped formations were thought to be precursors to the impending supernova explosion in theory, but they are also situated nearly exactly where one would anticipate them to be following a stellar cannibalism event. However, there are alternative explanations. Massive bubbles of rising and descending plasma adorn the star's surface, covering a significant portion of its visible outer shell, according to Ma's research team. This is the key. The red and blue shifts of the radio emission indicated above can also be caused by the fast motion of these plasma bubbles. In other words, it's plausible that Betelgeuse is producing an optical illusion rather than spinning excessively quickly. Even a star that is not rotating at all can appear to be rotating very quickly if a very large convection bubble, or a collection of them, is going in the observer's direction while another is moving away. This interpretation is not at all implausible, according to a recent examination of the ALMA data combined with an astrophysical model. Ma claims that the maps produced by the simulation had a 90% chance of being misunderstood as having large rotation speeds. The main cause of this is the ALMA photo's poor resolution, which warps the actual features of the movements on the stellar surface. Currently, the actual rotational speed of Betelgeuse and the likelihood of the swallowed star scenario cannot be determined with absolute accuracy. We can state, however, that there is growing evidence that the red supergiant is not, in fact, alone. Is there a companion star for Betelgeuse? As previously stated, Betelgeuse's surface and brightness fluctuate over a period of roughly 400 days. In actuality, the red supergiant is still recovering from the massive 2019 plasma eruption, and the surface continues to quiver like an enormous jelly as the explosion's aftereffects cause fast oscillations in its innards. Astronomers predict that it will take a number of years for the star to return to its typical cycle. However, Betelgeuse shows an additional, lengthier brightness fluctuation during a period of 2,170 days, or nearly 6 years, in addition to its 400-day pulsation. For a long time, the causes of these protracted periodic variations were unknown. Jared Goldberg and his colleagues at the Flatiron Institute in New York recently dedicated themselves to re-examining all of the observational data on Betelgeuse in an effort to ultimately change this. In fact, a number of unexpected anomalies were discovered by the new investigation. The first of these is that the star's light curve's 6-year cycle is governed by a distinct rhythm from the faint 400-day pulsations. Furthermore, no accompanying phenomena that would be linked to sources like convection currents, magnetic field effects, or rotation sequences could be seen by the specialists. In the end, the scientists came to the conclusion that the existence of a smaller companion star is the only plausible explanation for the long-period oscillations that does not have any fundamental problems. On the other hand, the odd 6-year variations would represent the companion star's orbits. The brightness of the secondary period decreases as soon as the star companion passes behind Betelgeuse as viewed from Earth. But when the companion is in close proximity to Betelgeuse, the two celestial bodies' luminosities merge and the brightness is at its highest. However, the companion star may also function as a natural dust mover, affecting the dust cloud distribution and contributing to Betelgeuse's variations in brightness. So far, so believable. However, why hasn't the companion star been found yet? Its low mass is most likely the answer to this query. Researchers claim that, according to estimations, Betelgeuse possesses about 20 solar masses, but it only weighs about 1.7. Additionally, at a distance of just 2.43 Betelgeuse radii, the companion star is probably going to orbit its much larger partner very closely. This arrangement causes the companion star to be greatly outshone by its more powerful counterpart, and Betelgeuse's pulsation and brightness variations make it much more difficult to find the companion's traces in the light curve. The experts now wish to apply for observation time at some of the large telescopes, despite the fact that the chances of seeing the companion star with today's telescopes are, to put it bluntly, slim. They do this in the hopes of finding more proof of the stellar partner's existence, and perhaps even identifying the type of star in question.